Alright, in this video, let's get started with the code for our new screen system. Here we're going to start with the screen class itself. Now this is going to be an interesting class because it is both going to be the instance framework. It's going to lay out the exact method interface that any given screen might use. And it is at the same time going to contain static elements that will provide our management system. That'll provide things like our dictionary of all available screens. It'll contain our stack of screens that have been used. So let's get this put together inside of the core folder. Over here in our Solution Explorer, I'm going to collapse down the content subproject, and you'll notice we have the core folder. I will add a new class to core, and we will call this screen. We'll give it just a second to load up. And we will clean up the sub namespace as well as add in the standard using statements. So using Microsoft.xna.framework. And then we'll simply duplicate this line like so. And we'll have framework.graphics. Because there are, of course, going to be some graphical elements of any given screen. Now, as far as the screen itself, we are going to mark the whole class as abstract. And the idea is that the base implementation of screen is not actually going to do anything, so it will simply prevent anyone from instancing any copies of it. Alright, now we can move into a handful of fields that we will need. First, we'll address the static fields. These will be public, static, and the first is going to be the actual stack container that we're going to use to keep track of ordering. So we'll make a stack of type screen. And we'll call this stack screen stack. And we'll go ahead and instantiate the stack container itself. Now we can move on to the dictionary that's going to hold all available screens. This will be a public static dictionary of type screen. Now, of course, we need to define both the value and the key type. And these screens, as we talked about before, are going to be addressed by strings. So we will have a string name. So that means the key is going to be of type string, and the value will be of type screen.
Okay.
We'll call this dictionary screens. And we'll go ahead and instantiate the dictionary container. Now, one last thing we're going to do is we will add a static property called ActiveScreen, and that will simply act as a wrapper to one of the methods found within the screen stack. With any given stack container, one of the methods available is called peek. That allows you to look at the top item without actually removing it or popping it off of the stack. So we'll put this in here as public static. This will be a screen property. We'll call the property ActiveScreen. And then we will add we'll add in the braces for the property. I was pausing just for a second because I'm going to write this out line by line, but once we get all the lines put together, I'm actually going to collapse it back up onto a single line just to save space.
Okay. So this is kind of like the floating eyeball we had in our drawing before.
Exactly. This is going to be that same idea.
Okay.
Matter of fact, it's that peek method, which goes along with the whole eyeball mentality. Is we'll look at the stack rather than messing with it.
All right.
Because in a lot of stack-based operations, you both look at and remove an item in one go. That's where you get the pop functionality for a stack.
Gotcha.
But in certain cases, it can be useful to just look at the stack, look at the top item without removing it. In cases like the frequent calls to draw and update. It would be inefficient on our side if we had to pull an item off of the stack to draw it and then put it back onto the stack to remember it was there. It's easier to just look at it and note the fact that it's there.
Well, we're not using the stack as a way to, it's not like everything that's currently inactive is being kept on the stack. Everything we're working with, including the current screen that is actually playing something right now, is still on top of the stack.
Right, they're all still contained. We're just interested in that one top item. So we'll put a get accessor into our property, And that get accessor is going to return the current screen. So we'll look at screen stack dot peak, and that'll look at the topmost item, and we'll do so without actually removing it.
Okay.
And now, just to save space, I'm going to pull out some of the line returns and put this all up on one line. Just since in this case we have a read-only property, so we only have a get accessor.
Sure.
And then we're just returning a specific value.
So the active screen is basically whatever's on top of the stack right now.
Exactly.
Yeah.
And really, the purpose of this property is more just for naming than anything else, because of course we could from any point look into the screen stack and run peek and do exactly the same thing that active screen is doing.
Sure. It's just easy to remember that the active screen is what we're playing with right now.
Right. It makes it a lot easier to reach into, because that way we just have to say screen.activeScreen instead of screen.screenstack.peak.
Right. Very nice.
All right, one last field that we need is going to be an instance field, and it's going to be the field that will hold the texture, the background texture, for the current screen. So this will be a private field, and in this case I won't even worry about the modifier on it. I'll just drop down a texture 2D field, which we will call background. And the idea is that, of course, any screen can have a background texture, and this is simply the field that will remember that texture reference, so that every time a call to draw comes up, we can just draw this background texture.
Okay.
All right. Now it takes care of all of the fields we'll need inside of the screen class. So let's put together the method skeleton. And starting from the top, we have the reset method. This will be a public virtual void method called reset. And we're not actually going to put an implementation into the screen class itself. Reset is meant to be overridden and used by classes that inherit from screen. So we'll just put the empty method body as braces out to the side. I'll note here that a lot of the methods, a lot of the instance methods, are going to contain very little code here in the screen class.
Yeah.
They're simply meant as the framework. You could say the method interface that all screens are going to share.
Sure.
Now, just a quick word on the reset method itself. The purpose of reset is anytime we need to tell the screen to go back to its starting state.
Okay.
In the case of a game, this could be where you've loaded up a game screen and you've played halfway through a song, but all of a sudden you jump back out of the game screen, go song select, and then reselect the same song and reload it. The idea is you don't want to jump back into the middle of the song off of the song selection screen. You want to always start at the beginning.
Right.
And so reset is going to allow us to indicate to the screen to say, all right, whatever your purpose is in life, go to the beginning of that purpose.
Okay.
If it's a song screen, it'll go to the beginning of the song.
Right, and that'll be something that'll be determined on a screen-by-screen basis. So, for instance, and it's kind of like a theoretical for instance, like on this song select screen, perhaps the initial state is just to have whatever the topmost song is selected as soon as you jump in, and not the middlemost song, or just something like that. For actually playing the game, naturally, you want to go all the way to the very beginning of the song. You don't want to pick back up halfway through a song, or heaven forbid, pick halfway back up through where the last person was playing, that sort of thing.
Exactly. All right, next up we have two more virtual methods, but these methods are going to be protected in type rather than public. I'll drop both methods in place, and then we'll talk about exactly what they do. So the first of which is going to be protected virtual void process show. And we will drop in our open closing parentheses and our method body. And I just noticed that here on reset we don't actually have our method parentheses.
Whoa.
So we'll drop those in as well.
Cool.
All right. Now I'll take this line for process show. I'll use copy and paste to duplicate it, and we'll make a counterpart for it called process hide. All right. Here's the deal with process show and process hide. These methods will be used to indicate to the current screen that it has just been made visible or just been made hidden.
Okay.
The idea is that we will actually code these calls in from inside of the screen class itself, and you'll notice that they are indeed protected, meaning no code outside of the screen system can even invoke these.
All right.
So these are guaranteed to be called once upon becoming visible and once upon becoming hidden.
And these are there just in case you have, or for when you have functionality that has to be shown when functionality that has to execute when a screen is shown versus when it's hidden.
That's right. One specific example with process hide, the actual way that these will be implemented is whenever a screen is pushed onto the stack, it's in that action of being pushed onto the stack that will call the process show.
Okay.
And the opposite is as soon as that screen gets popped and removed off of the stack, we'll call the process hide.
All right.
And this way the screen is given hints to say that, oh wait, I just got shown, I need to make sure that everything is ready for display. Anything that needs to be positioned, we'll get that in line. And then for process hide, one example is when we get into the record mode, when you finish recording your pattern and you may or may not want to save it. The idea is that as soon as the record screen is told that, all right, you're removed off the stack, it has the opportunity to know that and throw up a save screen.
Gotcha.
So that way we don't actually have to code in something from the outside. We don't have to say, all right, make a special button that invokes save. We can just say, whenever a record screen happens to go away, check and see if we need to save notes.
So process show and process hide basically translate to do this when showing or when shown and do this when hidden. And it's going to be functionality that will be unique to each instantiated screen.
Right. All right, moving on. The next method we have is some input handling methods. So we're going to go back to some public methods. So we will have public, and again we will have virtual, no return, so we have void. And these input handling methods are going to be called input pressed and input released.
Okay.
Now, input pressed and released are going to take in an input data struct. And we'll call this parameter input data.
Or unput data.
Whatever works. And again, we'll place the braces out to the side. Then we'll take and duplicate the whole input pressed method and change its name to input released.
And logically, these would only be here so that our screens can be aware that there are some inputs taking place.
That's right. This is where screens form a kind of, not just a mini game at this point, but a hybrid game. We're going to have things like update and draw, just like the real game does. But input pressed and released is going to be kind of managed at the game level, but at the screen level, we don't worry about having to run the update system. We just know that we're getting input events happening.
Gotcha.
And so those will be passed along into the specific screens via these methods.
Now let me ask you this. Is this how we're going to handle unique activities based on inputs on a screen-to-screen basis? By that I mean, like, let's say in the game Rock Band, as an example, when you're in some of the selection menus, you can play the drums and it'll take you down the menus, as opposed to playing the drums and playing notes?
In a way, that'll actually be handled at the key binding level.
Okay.
We'll swap out key bindings to give that functionality.
All right, so we're not quite there yet. I was just curious.
All right, this is just a way. Basically, the reason to have these methods here is we could also just go into the update method of any given screen, update the input system, and make some event handlers.
Sure.
The problem is we'd be doing that over and over again for every screen. Every screen we'd create, we'd make some new event handlers, and they would do... And then we'd have all this extra work of making the handler methods.
Cool. So we'll keep that external. We don't have to do it as much.
Right, and since we've already done that back in game,
Yeah.
we've already got these nice input pressed and input released methods. So instead, we'll just leave these handlers in place as the only handlers, and any input that comes through these events will just get passed on to the input pressed and input released methods. And at this point, once we're looking at internal inputs, we'll just pass along an entire input data struct, because that way we'll have things like what button was pressed, we'll have what player was it pressed for, and what track is it associated with. All right, moving on, we've got the update method. This will again be a public virtual void method called update. And we will take in the current game time along with our update call. So we'll take in a parameter of type game time, and we'll call it game time. And let's see, we will again put the braces right out to the side. And the reason we set up this method signature is that is just to match the normal game update method where we're passed in a game time here, so we'll just make sure that gets passed along.
Okay.
Since at this point in the design of the screen system, we don't know which screens may or may not need access to game time, so we'll just pass it along to make it available. Alright, moving on from here, we have the next method is going to be draw. And it is going to be, let's see, both public, virtual, and void. And let's see, looking through here, we'll take in a few different things for draw as well. We'll take in both the current game time and the sprite batch with which to draw. So I have game time called game time, and a sprite batch field.
So that tells us what to draw and when to draw it.
Exactly. And this one, I'll actually drop the braces below it, because when we get into some of the implementation details, we can address this one. As a matter of fact, there may be a few implementation details we can touch on here in this video, but I want to get the skeleton together first.
Sure. Yeah, just worry about the skeleton. We'll get the implementation done later.
Alright, the next method that we have, and really the last instance method, is going to be set background. So this is going to be public, virtual, void, set background. And set background is going to need to take in a texture. So we'll make a texture 2D parameter called texture. And again, we'll drop the braces below it. And that takes care of all the instance methods. As a matter of fact, just to kind of divide these up a little bit, I'm going to drop down a simple comment that says instance methods, just to make it clear how we're dividing these up.
Mm-hmm.
And like so.
Methods.
There we go. The reason we're doing that is because now, to finish off our skeleton, we need to drop in the static methods that will be present.
Okay.
So we'll drop in here. We can go ahead and make another comment. We can say that these are going to be the static methods. And these methods will consist of push screen, pop screen, and return to root. These are the methods that are going to facilitate the stack operations that will be used whenever we show or get rid of, or rather hide, various screens. So let's begin with the first one. We're going to have a public static method, void return, called push screen. And push screen is going to need to take in the name of a screen to be shown. So make screen name. And we'll drop in our braces. What's interesting about this method is it kind of combines the world of the stack functionality and our name-based dictionary. Because in this case, push, we're implying that we're going to be doing a stack operation of pushing an item onto the stack. But our stack needs to carry the type of screen.
Right.
And we would like to reference all of our screens by name rather than by instance. So the idea with push screen is it'll kind of be the go-between between the two worlds. It'll take in a name, it'll look in the dictionary and see if it can find that name, and if it can, it'll take that actual screen instance and drop it onto our stack.
Okay.
Alright, moving on from here, we have the counterpart to push screen, which is pop screen. This will be again be public, static, void, and we will call it pop screen.
Now this shouldn't need to take in anything, because really it's just whatever happens to be on top of the stack.
Right, just due to the nature of the stack itself, the idea that we can peek at the screen or at the stack and we're only seeing the top, just like the drawing you would put together on the whiteboard. That's really the idea that we have, is as though these items in the stack are opaque, meaning if we look at the stack, we're only ever looking at the top item.
Gotcha.
And so pop screen is going to do just that. Whatever happens to be the top item, he gets removed off of the stack. And being removed off the stack means that we're now looking at the item below him. And so that's how we get the idea of popping a screen will cause us to go back in the series of screens that have been shown.
Gotcha.
Alright, one last method we'll put together. This will be a public static void method called return to root.
And
we'll just take in empty parentheses, no parameters.
And not to jumble words around too much because I know we already have a reset method, but this is almost like hitting the reset button on your game console.
Exactly. This is at a much higher level. The idea here is that if we get into a scenario where we want to go and disregard the order of screens that we have on the stack and go back to whatever the first screen was,
Which is generally going to be the main
generally
screen.
the main menu.
Yeah.
You could almost call this method return to main, return to main menu.
Right.
Except for the fact that the idea of main menu hasn't been established at this point. This is all highly generic stuff.
Yeah. And you might want to change it at some point. I mean, I don't know, maybe it'll be like a splash screen or something you'd rather jump to. Who knows?
And the idea here is that this will prevent you from ever having to write a pop command in a loop,
Yeah.
to just pop all of the screens. So that's actually going to be the implementation here. That means if you ever want to just go walk backwards through all of the screens and get rid of them, then you can run return to root.
Cool.
And let's see here. With that,
is there anything else you want to add to the skeleton?
There is a few things. We're going to do this skeleton video just a little bit different.
Okay.
The instance methods, the few that we're actually going to implement, because you notice the idea I had going here is with the methods that had their braces up to the side, they're not going to contain any implementation at all here inside of the screen class. The only ones that are going to contain any implementation details at all are draw and set background. And those are so simple, and so much as a tangent to the way the screen system works, we're going to go ahead and drop them in right here.
Cool.
And we'll actually start with set background. Because all set background is going to do is look at the background field in the current instance of this screen and set it equal to the incoming texture. So we'll just take care of that right here.
Well, that's easy enough.
And the base functionality of draw is going to just be to draw that background. Now we will take into account the fact that the screen does not necessarily have a background. If we've never called set background, background is going to be null. And so we want to make sure that we avoid looking at that texture if it is null. So we'll put together an if statement before we draw it, and we'll say if this dot background is not equal to null, then we'll draw the background. We'll take our incoming sprite batch from the parameter. We'll tell it to draw, and we will draw this dot background for the texture. For the position, let's use overload 2. We'll specify the position as a vector 2, simply so that we can reach into vector 2.0 and place this at the top left corner of the screen. And for the color, we'll have no color modulation, so we will feed in color.white.
Okay.
So now we not only have a skeleton put together, but the few implementation details for the instances of individual screens have been put in place. And really, that functionality right now is just drawing the background. Now, coming up, we'll need to address the functionality in all of our static methods that manage screens. And we'll take a look at that here in the next video.
Awesome.